Imagine you're standing on the deck of a ship in the middle of the Indian Ocean. It's just past midnight on January 25th, 1995. The sky is black, the water is black, and you're surrounded by darkness in every direction. Then, without warning, the darkness beneath you begins to glow. The crew of the British merchant vessel SS Lima watched in disbelief as the ocean transformed before their eyes. A steady, uniform white light emanated from the water, stretching to the horizon in every direction. The captain, J. Briand, would later write, "The ship appeared to be sailing on a field of snow or gliding over the clouds." For 6 hours, the SS Lima sailed through 15,000 square kilometers of glowing ocean, an area the size of Connecticut. And satellite imagery would later prove this wasn't a fleeting illusion. The glow persisted for 3 consecutive nights. For centuries, sailors had reported these milky seas. Yet, because the glow is so rare and transient, the accounts were often regarded by the scientific community as unverifiable anecdotes or sailors' yarns. But in 2005, Dr. Stephen Miller changed history. By cross-referencing the SS Lima's handwritten logs with archived satellite data, he successfully detected the glow from orbit for the first time. This discovery provided the first physical proof of a massive biological event that researchers are only now beginning to understand. Scientists currently attribute the phenomenon to a process called quorum sensing, where billions of bioluminescent bacteria coordinate to produce a glow so massive it can be seen from space. This is the story of one of the ocean's most spectacular mysteries, a phenomenon that bridges ancient maritime lore with modern satellite science. This is the mystery of the Milky Seas. For over 150 years, ship captains documented encounters with Milky Seas. One of the earliest detailed accounts dates to 1864, when the captain of the Shooting Star described the waters as a plain of snow. By the late 20th century, scientists had compiled a database of over 230 such sightings, the vast majority occurring in the Indian Ocean, particularly during the summer monsoon season between Somalia and Indonesia. The phenomenon even captured the imagination of Jules Verne, who famously described the Nautilus passing through a sea of milk in 20,000 leagues under the sea. But the scientific community remained skeptical. Sailors had reported sea serpents and mermaids for centuries. Without physical samples or photographs, Milky Seas were often filed away as maritime folklore. The ocean, scientists believed, didn't work that way. Known bioluminescence was usually localized and patchy, the familiar sparkle of dinoflagellates, triggered by a crashing wave or a ship's hull. The idea of a uniform, steady glow covering thousands of square kilometers seemed to contradict the known laws of marine biology. In 1985, a potential breakthrough occurred. The research vessel RRS Charles Darwin accidentally sailed into a Milky Sea in the Arabian Sea. Researchers collected water samples and found high concentrations of the luminous bacteria Vibrio harveyi. Yet, this only deepened the mystery. These bacteria exist throughout the world's oceans in low concentrations. Why would they suddenly congregate in such staggering numbers? And how could they coordinate a glow so massive that it remained uniform across the horizon? For nearly 2 decades, the answer remained out of reach, and the ocean kept its secret. Until a scientist, looking for something else entirely, stumbled upon the proof. In 2004, Dr. Stephen Miller sat in his laboratory at the Naval Research Laboratory in Monterey, California, investigating a mystery. He had come across a 1995 report from a British merchant vessel called the SS Lima, which claimed to have sailed through a white sea for 6 hours. To most, it sounded like a tall tale, but Miller wondered if a satellite could have captured it. Searching for the evidence was like a needle in a haystack. Most satellite data from the 1990s was grainy and difficult to process, and he was looking for a faint glow in a massive, dark ocean. But while reviewing archived imagery from January 25, 1995, he found it. a strange, comma-shaped smudge in the northwestern Indian Ocean. This diffuse, uniform glow appeared at the exact coordinates and time reported by the SS Lima. The captain's description, sailing over a field of snow, matched the satellite anomaly perfectly. The glowing area measured approximately 15,400 square kilometers, roughly the size of Connecticut. Even more incredible, the satellite proved the glow wasn't a fluke. It had persisted and rotated with the currents for 3 consecutive nights. Miller published his landmark findings in 2005, marking the first time a Milky Sea was scientifically confirmed from space. His work turned a maritime legend into a modern scientific hunt. Today, in 2026, we no longer wait for ships to stumble upon these mysteries. Using advanced sensors like the day/night band on modern satellites, Dr. Miller and his team have tracked Milky Seas as large as Iceland, proving that these glowing giants are some of the largest biological events on our planet. Even with satellite proof, scientists still lacked ground truth. We had pictures from 850 kilometers, about 530 miles, above the Earth, but no one had ever captured this ghostly glow with a modern camera from the deck of a ship. That changed in August 2019, when a private sailing yacht called the Ganesha accidentally sailed into a massive Milky Sea south of Java, Indonesia. For the first time in history, a crew used smartphones and GoPros to document the snow field of light. Because these cameras often struggle with low light, scientists later carefully color-corrected the images to match exactly what the human eye sees: a soft, uniform white glow that made the boat look like it was floating in a bowl of milk. These photos confirmed a living, breathing reality, providing undeniable proof of the phenomenon seen from space. The Ganesha's discovery transformed Milky Seas from an ancient legend into a legitimate scientific mission. But it also raised the ultimate question: what kind of biological power could generate enough light to be seen by a satellite orbiting 500 miles above the Earth? Now that we knew Milky Seas were real, the question became, how? Researchers turned their attention to the bacteria found in those 1985 samples, Vibrio harveyi. These tiny organisms produce light through a chemical reaction. An enzyme called luciferase burns a molecule called luciferin. But here is the catch: a single bacterium doesn't glow on its own. It only turns on its light when it knows it has enough friends nearby. This is a phenomenon called quorum sensing. Think of it as a bacterial democracy. Each bacterium releases a tiny chemical ballot into the water. When the water becomes crowded with these ballots, the bacteria realize they have reached a majority. In a split second, billions of them vote to turn on the lights. To create a glow bright enough for Dr. Miller to see from 850 kilometers above Earth, you need a staggering crowd. About 40 billion bacteria packed into every single square meter of the ocean's surface. In an event the size of the SS Lima sighting, that adds up to 600 quintillion bacteria. That is 600 million trillion individual organisms, all coordinating their light across an area the size of a small country. But what are they all eating? How do they survive in such huge numbers? The late Dr. Kenneth Nielsen and his colleagues discovered the answer: massive algal blooms. Imagine a floating meadow of algae stretching for miles. As the algae die, they create a feast for the bacteria. These decaying blooms act like floating bacterial cities, vast, nutrient-rich platforms where Vibrio harveyi can multiply exponentially until they reach that magic number where the lights switch on. To understand how this mystery unfolds, think of it as a 3-stage biological event. First, the feast, the algal bloom. It begins with a massive algal bloom, a sudden explosion of tiny marine plants triggered by the perfect mix of sunlight and nutrients. These algae form thick meadows on the ocean surface, sometimes stretching across thousands of square kilometers. Then, the colonization, the bacterial city. Luminous bacteria, specifically Vibrio harveyi, find this floating meadow and begin to feast. They multiply at a staggering rate, turning the dying algae into a crowded, high-density bacterial city. Finally, the vote, quorum sensing. Once the crowd reaches a critical mass, about 40 billion bacteria per square meter, they begin to talk to each other using chemical signals. This is quorum sensing. The bacteria effectively vote to turn on their lights all at once. Unlike common bioluminescence that only sparkles when splashed, this light stays on steadily, like a living lamp, as long as the population stays dense enough. The result is a uniform, ghostly glow that blankets the horizon. To a sailor on a ship like the SS Lima, it looks like a field of snow. To a satellite 850 kilometers above, it appears as a glowing smudge in the dark heart of the ocean. The display only ends when the meadow drifts apart or the food runs out, causing the bacterial population to drop and the lights to finally fade. Since Miller's 2005 discovery, scientists have identified dozens of additional Milky Seas in satellite archives. Most occur in the northwestern Indian Ocean, particularly in the Arabian Sea and the waters off Somalia. In 2021, Dr. Miller and his team published research in scientific reports using the day/night band sensor, a high-tech night vision camera on modern satellites. They discovered that Milky Seas are more common than we thought, occurring several times a year. We just didn't see them because they usually happen in remote parts of the ocean where ships rarely travel. And here is the final piece of the puzzle. A massive study released in 2025 by Dr. Miller and Justin Hudson at Colorado State University compiled a 400-year database of sightings. They revealed that these events aren't random. They are tied to the pulse of our planet's climate. In the summer, they peak after La Niña events, which change how nutrients move in the ocean. In the winter, they emerge during the positive phase of the Indian Ocean Dipole, a giant seesaw of ocean temperatures that pushes nutrient-rich water toward the surface. As of early 2026, scientists are using this climate fingerprint to predict exactly when and where the next Milky Sea will appear. It's like a weather forecast, but for glowing oceans. From a biological perspective, Milky Seas are the ultimate example of teamwork. Billions of bacteria synchronize their lights in a display unmatched by anything else in nature. But even with all our technology, one big mystery remains. Why? Why does a tiny bacterium spend so much energy to glow? In nature, nothing is free. Every spark of light costs resources that could be used for growing or reproducing. There are three major theories being debated by scientists in early 2026. First theory, the hitchhiker's guide. Dr. Kenneth Nielsen's team suggested the light acts as an eat me sign. By attracting fish or zooplankton to eat them, the bacteria survive the trip through the predator's gut and get pooped out in a brand new location with fresh nutrients. It's a brilliant way to travel across a vast ocean. Second theory, the carbon mystery. Research from late 2025 suggests Milky Seas might be a massive, hidden part of Earth's carbon cycle. By gathering in such quintillions, these bacteria might change how marine snow, falling organic matter, sinks into the deep ocean, helping the planet breathe by locking carbon away. And the third theory, the pathogen warning. Some researchers worry these glows are a distress signal. Since Vibrio harveyi can be harmful to shrimp and fish, these massive blooms might be a symptom of an ocean pushed out of balance by rising temperatures. This mystery keeps astrobiologists awake at night. As NASA's Europa Clipper hurtles toward Jupiter's moon, scientists are asking, if bacteria on Earth can create light shows visible from space, what are we missing on other worlds? Could the frozen oceans of Europa be hiding their own Milky Seas beneath kilometers of ice? The machine learning tools Dr. Miller developed to find glowing water on Earth are now being adapted to hunt for life on other planets. What began as a sailor's yarn is now a tool for finding aliens. Somewhere tonight, in the warm currents of the Indian Ocean, the bacteria are gathering. They are feeding, multiplying, and talking to one another through chemistry. When they reach that magic number, the sea will turn to milk. It is a reminder that the smallest forms of life, organisms you can't even see, can create a light show visible from the stars. They coordinate across distances that, to them, are like us, shouting across continents. They do it without brains or eyes. Just chemistry, just life, finding a way to thrive in the most spectacular ways possible.
The ocean continues to surprise us, revealing phenomena that challenge our understanding of life's limits and capabilities. If this journey into the glowing depths fascinated you, illuminate our work with a like, share your thoughts in the comments below, and subscribe so we can explore more of Earth's mysteries together.